Currently, there are 118 elements that we have discovered and logged on the periodic table. Elements are strange things. Simply adding or removing a single proton from the atom's nucleus of an element completely changes it and essentially makes it a new element. Here are the weirdest elements from the periodic table that seem to defy the laws of physics. First up is gallium, a soft metal often used in semiconductors. Its unique feature is its low melting point of around 29.76 degrees Celsius. This means it can melt in your hand and then resolidify once it cools below its melting point. In the early 20th century, a popular prank amongst chemists at universities was to smelt gallium into utensils and then watch as their classmates' forks and spoons melted away from their hands as they ate. But if you think a metal becoming a liquid at room temperature is weird, how about a metal being a gas at room temperature? I am talking about Copernicium, which is a highly radioactive metal. It is one of the weirdest and most elusive elements for two reasons. Firstly, it decays extremely fast, with an astonishingly short half-life of just 29 seconds, so it doesn't stick around for very long. And secondly, it is a gas at room temperature. Both of these factors make it extremely difficult for scientists to study. As a result, we still don't know very much about this elusive substance. Next up is Curium. It is an extremely radioactive substance that was named after Marie Curie, the scientist who discovered radium and polonium. Only a few kilograms of curium are produced each year because it doesn't have many uses. However, it was used on a Mars mission in an alpha-proton X-ray spectrometer. But what makes this element so unique is that it's so radioactive that it actually glows in the dark. It emits a faint blue light when it decays. Up next is Francium, a naturally occurring element named after France. This alkali metal is highly reactive and extremely rare. It usually appears one atom at a time before disappearing almost immediately due to its short half-life of 22 minutes. It is estimated that there are only about 20 grams of francium on the planet at any one time. Scientists aren't even able to procure a sample of francium large enough for it to be visible to the naked eye. Therefore, studying it is almost impossible. Theoretically, we know that when put into water, the reaction would be spectacularly dangerous. It's far more reactive than cesium, which explodes on contact with water. Next, we have a group of different elements, known as the Transuranium elements or Superheavy elements, which are relatively new additions to the periodic table. They are all man-made, and they were all discovered in the exact same manner, by scientists bombarding atoms of one element with atoms of another element. This process momentarily creates entirely new elements. The first transuranium elements discovered were neptunium, 93, and plutonium, 94, both found in the 1940s. Even though the existence of these elements has been confirmed, further investigation into their properties and potential applications continues. Next up is bismuth, which is the heaviest non-radioactive metal that can be considered stable for practical purposes. Actually, it is very, very slightly radioactive. But bismuth has a half-life of over 100 billion years, which is much longer than the age of the universe. So for argument's sake, it's fair to say that it's completely stable and can be practically considered non-radioactive. Bismuth is used in medicine and cosmetics, but it has a unique attribute. It is diamagnetic. This means that when an external magnetic field is applied, bismuth generates a magnetic field in the opposite direction. In layman's terms, if you put a magnet between two pieces of bismuth, the magnet levitates. Next on our list is sulfur. You probably imagine sulfur as a yellow rock, but it can actually change to different colors in different conditions. One of the weirdest such examples can be seen if you melt sulfur. It turns from a solid yellow rock to a blood-red liquid. And if you burn sulfur, it produces a neon blue flame. But sulfur has a disgusting side. It's responsible for the smell of rotten eggs, garlic, onions, and many other nasty smells. In fact, most things that smell bad have some sulfur in them somewhere. Up next is helium, a colorless, odorless, tasteless, and inert gas, which means it doesn't readily react with other elements. It is the lightest element, with an atomic mass of just 4. It has the lowest boiling and melting points among all elements. At an unimaginably low temperature of minus 272.2 degrees Celsius, helium turns into a superfluid. This exhibits a unique property. If you pour helium in its superfluid form into a vessel, it seems to defy gravity and creep up the walls of the container, flowing over the rim to try and reach a warmer place, where it will eventually evaporate. It is not the only element that can form a superfluid. Other elements that can do this include hydrogen, neon, and argon. If it weren't for this next element, you wouldn't be watching this video right now. I am, of course, talking about silicon, a crucial component in all computer chips and most electronics. It even has an entire valley named after it in California. It's also responsible for silky white beaches, being the most common component in the sand. Oh, and don't forget breast implants. It's one of the most common elements on Earth. About 27% of the Earth's crust is made up of silicon. Silicon is a remarkable element because it's largely responsible for the technological revolution of the past few decades. And finally, it may not be particularly strange, but it is arguably the coolest element. The element I'm talking about is carbon. It is one of the most essential elements to support life. It is the building block of everything living. DNA, proteins, cells, coal, pencils, diamonds, the air you breathe, and the food you eat are all made up of carbon, as well as countless other things. Carbon comprises 20% of the weight of all living organisms. To put it simply, if it weren't for carbon, we wouldn't be here, and neither would the universe as we know it. For that reason alone, it deserves some attention. And there we have it. Which one do you find the most fascinating or unusual? Share your thoughts in the comments below, and don't forget to subscribe to our channel for more mind-blowing facts. Thanks for watching.